Hi friends, in this video we see about the topic wave motion. Wave motion is a mode of transmission of energy through a medium in the form of disturbance. So wave motion is the transfer of energy. Okay. Then it is due to the repeated periodic motion of the particle of the medium about an equilibrium position. This wave motion happens the periodic motion of the particle of the medium in an equilibrium position. Okay, that periodic motion is transferring the energy from one particle to another. Okay, so we can define the wave motion. It is a form of disturbance which travels through a medium due to the repeated periodic motion of the particle of the medium about their mean position. The motion is transferred continuously from one particle to its neighboring particle. Okay, next we see what is characteristics of wave motion, or what is the property of this wave motion. Okay, so the first one is it is necessary the medium. Okay, so the medium should be possesses elasticity and inertia. The second property is all the particles of the medium do not receive the disturbance at the same instant. That means each particle begins to vibrate a little later than its predecessor. Okay, so the wave velocity is different from the particle velocity. That is, the velocity of a wave is constant for a given medium, whereas the velocity of the particle goes on changing. Okay, and it begins maximum in their mean position and zero in their extreme position. Okay, so we consider the wave velocity, it is constant one, but particle velocity is changing. Okay, next one, during the propagation of wave motion there is transfer of energy from one particle to another. Okay, so here when the wave motion happens, there is energy only transfer from one particle to another, but the particle does not transfer. Okay, so there is transfer of energy from one particle to another without any actual transfer of the particles of the medium. Okay, so the wave motion undergoes the reflection, refraction, diffraction and interference. Okay, so the next one is there are three types of waves. Okay, the first one is mechanical waves. Okay, mechanical wave means there is the media which possesses the wave motion happens the media which possesses elasticity and inertia. Okay, that type of wave is called the mechanical wave. The example for mechanical wave is water waves, sound waves and seismic waves. Okay, so the next one is electromagnetic waves. So this type of electromagnetic waves do not require any material for propagation, or it does not require any medium, okay, for spread the waves. Okay, so the example for electromagnetic waves are radio waves, microwaves, infrared rays, visible light, ultraviolet, X-rays and gamma rays. Okay, these are the example for electromagnetic waves. The next one is matter waves. So the matter waves means the wave is the particle is considered as a waves. Okay, so that means the wave associated with particles like electrons, proton and fundamental particle in motions are matter waves. Okay, so we consider the particle as a wave. Okay, that type of wave is called the matter waves. Okay, so in mechanical wave motion there are two types is there. The first one is transverse wave motion, the second one is longitudinal wave motion. Okay, first we see about what is transverse wave motion. Okay, transverse wave motion is that wave motion in which particle of medium execute simple harmonic motion about their mean position in a direction perpendicular to the propagation of the wave. Okay, so transverse wave means it executes simple harmonic motion and its direction is perpendicular to the direction of propagation. Okay, so the example for transverse wave motion is waves produced by plucked string of veena or sitar or violin. Okay, so the next one is this transverse waves travel in the form of crest and trough. Okay, so first we see about what is crest. Okay, crest means the maximum displacement of the particle in the positive direction. That means we consider that is the particle in the above mean position. Okay, so trough means the maximum displacement of the particle in the negative direction. Okay, that is below its mean positions. Okay, that you see in this picture here, B and F are crest. Okay, that is the positive, the maximum displacement of the particle in the positive direction, but below that is D is in below, that is called the trough. Okay, that's maximum displacement of the particle in the negative direction, or we can say that below its mean position, that is called the trough. Okay, so transverse wave can be produced in solids and surface of liquids only. Okay, so we obtain the transverse waves only in the medium solid and liquid. Okay, so transverse wave cannot produced in gases and liquids because gases and liquids do not have rigidity. Okay, so this type of transverse wave cannot form in the gases and liquids. Okay, so the next one is longitudinal wave motion. Okay, so longitudinal wave motion is the wave motion in which each particle of the medium execute simple harmonic motion about its position along the direction of propagation of the wave. Okay, so in transverse wave, it is the perpendicular to the direction of propagation of the wave, but in longitudinal wave motion, there is along the direction of propagation of the wave. Okay, so here the example is sound waves in fluids. So in fluids means that is liquid and gases. Okay, this type of waves formed in the liquid and gases. So in this longitudinal wave motion travels in the medium. It forms two types. The first one is compression. So compression means the region where the coils are closer to said to be in the state of compression. Here we consider the one spring coil. Okay, so that coil are closer to the region, the coil in the region or closer or said to be in the compression. The next one is rarefaction, means the region where the coils are further or said to be in the state of rarefaction. Okay, it is some larger gap in this region. That region is called the rarefaction. But in compression, there is very close regions. Okay, there is no gap. Okay, so the region where the coils are closer is called the compression. Rarefaction means where the coils are further or said to be in the state of rarefaction. Okay. Next one, important terms used in wave motions. Okay, first one is wavelength. Wavelength is lambda. So wavelength means the distance travelled by the wave during which a particle of the medium completes one vibration is called the wavelength. So okay, wavelength is a distance travelled by the wave. Okay, for it complete one vibration is called the wavelength. Okay, so in a transverse wave we calculate the wavelength, that is distance between two successive crest or trough. Okay, that is the wavelength for transverse wave. But in longitudinal waves there is a distance between two successive compression or rarefaction. Okay, so this type of wavelength can be calculated. Okay, so in transverse wave we calculate the wavelength using two successive crest or trough, but in longitudinal waves we consider two successive compression or rarefaction. Okay, so the next one is time period. Time period means it is a time taken by the wave to travel a distance equal to its wavelength. Okay, so the wave it is the wave traveled time. Okay, the distance equal to its wavelength. Okay, so we define the time period T is time taken by the wave to travel a distance equal to its wavelength. Okay, next one is frequency. So frequency means number of waves produced in 1 second. Okay, so that means a number of waves n equal to 1 by t. So that is frequency is reciprocal of time. Okay, reciprocal of time, that is 1 by t. Okay, next one we can write the relation between velocity, wavelength and time. Okay, that is velocity is defined as the distance travelled by a wave in a medium in 1 second is called the velocity of propagation of the wave in that medium. Okay, so the relation between velocity, wavelength and time period t is v equal to lambda by t. Okay, so we already know that is n equal to, that is frequency n equal to 1 by t. So we substitute 1 by t equal to n. So the velocity v equal to n lambda. Okay, so that is the relationship between velocity, frequency and wavelength. Okay, so that's all friends. Thank you.